So wonderful, good morning. My name is Dennis Narz. I'm working at Feynsinn as a sales manager. I'm very happy to be here today, and with me is my colleague Jan Berner,
Hello,
who's head
everybody.
of technology and processes here at Feynsinn. And our small presentation today is about XR technology in the field of production. So a small agenda for today. First, I'm going to introduce you to Feynsinn. I tell you why we are strong together with the EDAC group. I talk about digital transformation in the example of XR in the field of production. And the second part of our presentation is will do my colleague Jan Berner, who's giving an overview of a use case we did together with Bosch Rexroth. So Feynsinn, who's Feynsinn? We are technology providers, but we have implementation competence, which means our team consists of engineers, IT experts, and artists who work hand in hand together to improve the knowledge of our customers and help them to get better and stay best in their various fields. Moreover, we now integrate and create digital solutions to improve the engineering, the production, and the marketing processes of our customers. So let's have a short closer look on the ecosystem we are dealing with. So first, there are our engineers, who having a focus on the engineering department of our customer and help them to increase their productivity by, for example, training, by doing standardizations, by doing creating methods. And if you have standardized processes, you're able to automate them with small software solutions to help the engineers to do their real work. Then we have our software developers who create bridges between different departments. For example, creating bridges between the engineering department and the production department by making all information available in the CAD files, so the part is produced without needing any paper because the information is provided machine readable. Then second part of our team are our visualization experts. At Feynsinn, like in many companies, everything is about data. And the data that is created in the engineering department and routed through the company by our software developers, then our artists came to the game. And they create awesome pictures, movies, and last but not least, and the most important point for today, they create awesome XR technologies for our customers. So just small key figures. We are founded in 2007, have 5 different locations, 130 experts. Yes, and I counted on Friday 276 customers. And I end the Feynsinn presentation with a small quote of our head of Feynsinn, who says, Feingefühl is the satisfaction you get when you suddenly understand how something can be made better. So strong together. Now I introduce you to Feynsinn, and there's another player in the game who is EDAC. Feynsinn is part of the EDAC group. EDAC is one of the biggest independent engineering companies in the whole world with around 8,000 employees. And EDAC Production Solutions have their focus on the production, which means they are able to engineer, to plan, and to realize and build whole factories, including the machinery and, for example, assembly lines and so on. So there are mechanical engineers, electrical engineers, automation experts, logistic experts, so everything you need to understand how production works. And this partnership is the reason why we can believably offer valuable XR solutions in the field of production, because we have the IT specialists, the artists, and the knowledge in production to understand what our customers do really want. So let's focus on what is really important. It's our customer. And what does our customer want? They want to reduce their costs. They want to increase their efficiency, very often driven by innovation. They want, of course, quality and motivated employees. And then we have Feynsinn, like I told you before. We have the know-how in processes and methods. We have the know-how in software and hardware that is used in the production. We have the knowledge in, for example, developing interfaces. And we have the competences in visualize things. And then we create XR experiences and integrate that in the IT infrastructure of our customer, which is really important because there are certain benefits who came up. So now I come to the main topic of our presentation. It's the fields of expertise we are working in. So the first field is the planning and the training. And for example, in the planning phase, we help, for example, the blue-collar worker or the machine operators, we integrate them in the planning processes. So very often, if you know a planning process of a company, there are highly qualified employees who are able to control complex software. And there we integrate very intuitive and easy software solutions that the machine operators can integrate their knowledge directly in a very early planning phase. For example, they use a headset and try ergonomical studies in a very early phase. Then we have the training field. Training field is very complex and it's very bright and different possibilities in there. For example, you can create virtual augmented reality applications, for example, for screwing, for welding, for painting. And you have a lot of benefits. For example, you can't, like I think EOS said, that you can't destroy your machine because you're doing this in virtual reality. And they have brought a use case. So we had one of our customers, it's the company BMW, who came to us and said, okay, Feynsinn, you're always telling in the industry that you're experts in digital transformation and you have bright skills. We have a problem that we need to save costs and increase the efficiency in the painting processes. And the solution we have built, you can see here on that picture. So we have modified a spray gun, you see on the picture here with sensors, and you are actually able to steer through your software by using that realistic and real spray gun. So you are able to, also integrate environments of our customers, like you see on the TV screen. You are able to, for example, integrate CAD parts, what you want to train. For example, a hood of a car or a door or whatever you want. And then you can take the spray gun and try the training, and you get a real-time evaluation, which means the software says, okay, you are too fast or too slow, or you're too close or too far away from the work part, or you're using, you haven't got the right angle, for example. And another big and important point is the gamification. So our software is designed for trainees and young students. And you can believe if you have a high score, if you are directly rated, then the motivation of the colleagues and trainees is significantly higher because they can compare to each other. So we have integrated a high score list or gamification elements like thumbs up, thumbs down, and so on. So the benefit was we had motivated students and trainees, and of course we had no waste of paint. Yeah, because you are training virtually, you don't use any paint, you don't have to clean your part after you're doing the training job, for example. And yeah, together with our customer, this was a very big success story because BMW uses our tool worldwide in their factories, and they have replaced the training first phase, the first I think 2 months of the training process by our virtual reality software. So now I come to the second field of expertise we are in. It's the maintenance and service point, or service field. So in the maintenance, you see again on that picture here in the middle, the machine operator wears an AR device, for example, a Microsoft HoloLens. He looks, for example, on a machine or on a part, and the software and the AR headset directly recognize the part or the machine. And even if he doesn't know that machine, he is guided through by digital hints and clues through that maintenance sequence step by step. So there's no need of physical documentation like books where you have to look up, oh, okay, what kind of machine is that? How's the maintenance process? Or on which page is it? So you can directly start the maintenance program even if you don't know the machine. So maybe there's a point where also the digital clues don't help you. Then you can call back in your headquarter, and a headquarter agent can look on the machine directly through your eyes by the device and give you hints and tips in real time. Also, if you integrate the software solutions in the IT infrastructure, you are able, if you see in the maintenance sequence that a part is broken, for example, you can mark these parts and send them through to the purchasing department, and the purchasing can directly order new parts for that machine, for example. And there's also a function like augmented social reality. So if a machine worker sees a difficult part or a difficult step, he can take annotations, and if in the next maintenance interval, a colleague can come and he can see or can display these annotations made by his former colleague. And again, I brought a short reference for that. So we did exactly what I just explained for Tier 1 in the automotive industry, who wanted to have intuitive software to enable employees to maintain unknown machines. And the result was a guidance maintenance by displaying AR content on the real machine. We used for that use case the Microsoft HoloLens. And we also integrated a note function, just speech to text, so that he doesn't have to type anything, for example. Yeah, the benefits are on the hand. So we have reduced the errors in the maintenance significantly, and the machine downtime is also decreased. And you have no need of handwritten documents anymore, because the solution is fully integrated in the IT backbone of our customers. Like the example I talked about with just marking parts and send them to the purchasing department who can directly order these parts. So last but not least, I come to the post-production quality check and quality assurance for example, for audits. There you see it again on this picture here. You can, for example, take a tablet and go to your machine or your work part and use the camera function and focus on your machine. And then the solution or digital software just compares the real machine with the target state of the machine based on CAD data. So and maybe there are deviations from the real world and the CAD data, and the software can automatically mark deviations, and you just can click to clicks, and you have a digital protocol of your audit. And again, the reference for that, we have done it with a Southern automotive OEM who wanted to have digital support for the product audit. And the solution you can again see here on the screen. There's a whole body in white, a car body, and you can walk around that car body with your tablet, and you can check if there are any faults or mistakes or something's broken. And you just take your tablet, use the camera function, can mark, use the speech to text function, and you have automatically, and if it's linked to the quality management software directly, so if it's integrated in the IT backbone, you have no need of any handwritten documents and papers anymore. Yeah, the benefits, this was what I just told, and it's also very intuitive and easy. You just can walk around, mark that and describe that, and then you are already done. So, thank you. Now we come to the second part, the use case we did together with our customer, Bosch Rexroth.
Thanks, Dennis. So normally our solutions are fully integrated in the IT ecosystems. And what we've seen before was some kind of a digital twin. And here also we have an example of a digital twin we did together with Bosch Rexroth. But first of all, let me take you to a quick traveling time back. So in 2017, we had the vision that we could control a production line from all over the world, sitting at home at a sofa, meeting there with different people to control the industrial lines. We did a demo of that. We used Unity for the visualization, and we had a collaboration system behind that based on Photon. And that was shown on the ERE in Nuremberg in 2018, and we got a good response, and it was a great success. In 2019, Bosch Rexroth came to us, and they said, we want to have a visualization system with which we can display virtual and existing machines easily, and we want to see all the additional data. They also said we want to have a possibility, if there error occurs, we want to get back in time and to see why the error occurs. Also, it has to be fast and predictable. That was what we wanted to have on this software, because we did something in the past like that, and we had a strong Unity expertise. We came together. So We two experts, us from ERW20, Feynsinn, we know how to plan, optimize, construct and validate production plans. And Bosch Rexroth, as a component supplier who has a lot of these parts to sell, we use to build a production line. We shared this vision, and this vision was the production line should be sawn from all over the world. So you all know that local is the new bio. So we will probably see in the future more and more production lines that are nearby the customers, that are smaller. And you don't have an expert for these production lines in front there. You have an expert somewhere else. So you need the possibility to control your production line from somewhere else. Also, we saw a lot of protection from a border. For instance, North America. If you produce a car today in Germany and you have a production line designed here, you can't just take the car, produce it here and bring it over. You have to produce your goods in North America. And therefore you have production lines in America and you don't have experts probably there. So you have an expert sitting here in Germany, and therefore you need the possibility to see what's going on in production from here and not in North America. Also, it should be possible to press a button and see when an error occurred, why is this error happening? So you have to get the possibility back in time and to see wherefore this error occurs. And it should be able that you optimize your production plant while it is running, and to see if you optimize it, is that all right or is there causing some problems. And last but not least, it should combine different platforms from different vendors. And all this is the idea that came together in ArtiViso. Potential use cases for ArtiViso are virtual commissioning. That is what we as ERW Production Solution do a lot. That means you plan, you optimize and you validate your production line before you even build it. But there is a lot of software in place that can do that. But also ArtiViso is possible to do this job. And the second one is running through operation for status quo, for optimization and for validating your production line. The scope. So let's have a quick look how that technically works. So we have a central control unit in the production line, normally the MAS, Manufacturing Execution System, that controls all your production line. And because that is based on signals, for instance, if you think of a conveyor belt, you just have an on-off state and the conveyor belt starts to moving. So you have to transfer that into positioning data. And all these data, the positioning data and the signals from the MAS gets fetched to TIM. TIM is a part of software from Bosch Rexroth who is really optimized to handle large data sets and is very fast. So we have these two layers. We have a real world layer and we have a digital layer. And in the real world layer we have a robots over here, and these robots also pass back positioning data to TIM. That is because if you have your MNS system and just get the signal, you don't know if the robot is doing the right thing, and so you can control that the right thing is done. And that gets all this back to TIM. And when it comes to ArtiViso, ArtiViso is the visualization software based in Unity, where you can see what's really going on in production, and that is controlled by TIM. So how does that look like? I've brought a short movie with it. So in here you see one of our test files that is driven by a record. You have a timeline on top. You can freely move in the view. You can display different parts like you see in here on the HUD display. You can take each parameter and bring it to to add. So you are really aware of what's going on in production, and you see everything. You have additional things like the timeline inspector, where you can bring in also sensor data and different data to just debug these things. That all is based on Unity. That means that it's very flexible. It could be customized for different needs. So it's yeah, really the way to see what's going on in production. So we have seen a lot of things from Dennis, who showed us some examples, and from Bosch we did to RTV. So we think in future, and I think you all think the same idea, that in future in production most people are wearing these glasses, because you're getting all the information, the right information to that glasses, and therefore you need a digital twin. And we think that that future starts now. Why do we think this starts now? I mean, we have seen a lot of devices in the past, like the HoloLens one, but we think that devices weren't production ready. Right now, the devices with the HoloLens 2, we see late last year, early this year, with a new iPad with a LiDAR scan, with glasses from Vio. We see more and more devices coming up that are production ready, and we think the time is now. And now also the software is in place, who is robust, who is practical to do all the AR tracking, and the SDKs are here. So we think right now the future starts, and we will see from now on a lot of helpful things for production. So that was from our lecture. Thanks a lot. That's from Dennis, Narz, and myself. So we will be around, and we will, yeah, hopefully meet each other in some discussion.
Yeah,